Almost every lunch period, my friends and I play a little game known as ducking. It's a quirky little platformer shooter where the goal is to place your bullets in a trajectory where it hits your friends. And man, am I bad at it. And it's not my fault. The game is difficult. It requires good timing, good hand-eye coordination, good map awareness, all that jazz. Or does it? Being the man-child that I am, my ego's constantly getting shattered each time they hit a beautiful ankle shot. Or I walk off the map of my own accord. Yeah. However, one day looking through my YouTube feed, I found a video about AI development and thought,
hey, I've experienced in Unity.
and the idea just clicked. Here's the plan. I'll recreate Duck Game from the ground up in Unity and train an AI inside, pitting it against itself until it becomes a beast at the game. Then I have it win against my friends, and my honor is restored.
And Billy wins 10-7.
With that being said, let's get started.
Meet Billy. He's a rectangle. For now.
He shares the hitbox and the mass of the player, and for now, can't move at all.
Like a good programmer, I tried to make Billy move by reusing a script I had laying around from a previous project. Unlike a good programmer, it doesn't work at all. But first, let's make an environment for Billy. This is a test chamber. Four walls, ceiling and a floor, and we're done. Wait, Josh, you might be asking, why did you add a checkerboard to the end of his room? Well, Johnny, the plan is to time the player's movement and recreate them in Unity. I know that Unity uses a 1 by 1 meter grid, so I can probably just math everything out. For example, if the in-game player runs 8 checkers per second, I can probably just set the running velocity of Billy in Unity to 8 meters per second. And after a quick check with a stopwatch, we had horizontal movement. That was pretty easy. Jumping and falling probably would just be as nice. No. It's been a month, and with the help of ChatGPT, I've gotten nowhere. The jump just isn't explosive as it is in the real game, and I was floundering. So, out of desperation, I reached for local Floridian expert, wrestler of crocodiles, a good friend of mine, Drew. Dovru? Here's how the conversation went. But Billy's movement is far from complete. Oh no, Billy's exceeding his terminal velocity and is barreling towards the ground. What are we going to do? Give him a parachute? Nah. Instead, with fall clamping, his velocity cannot exceed a certain point. Well, what if he doesn't want to break his legs when he lands? Say a little hovering. Now, Billy can put those good arms to use. Here's some more spaghetti code for the plethora of issues I had during this. Documentation in the description. Oh hey, Bracky's back. Here's me implementing coyote time and jump buffering. But wait, Josh, what is coyote time and jump buffering? Well, I'm glad you asked, James. Have you ever played a 2D platformer and thought, well, that's thanks to these two mechanics. Coyote Time, aptly named after the cartoon show Wile E. Coyote, is based off a common fact known by many people born in the early 2000s. If you fall off a cliff, as long as you don't look down, you can keep moving. Coyote Time is somewhat similar, giving players a small window of time after they fall off a platform to still be able to jump. Jump buffering is exactly how it sounds. Even if a player inputs jumping slightly before the character touches the ground, the character still jumps. With that all over, it was time to move on to... After staring at white boxes for hours on end, I decided it was finally time to add some animations. But it's such a shame that I don't have the Duck Game sprites, so I guess I have to make... Oh, there they are. After figuring out some small issues, Billy can now walk and stop around the map. Now to add animations to his jumping and falling. After figuring all of that out, it was on to sliding, because currently, Billy can do this. Logical errors really tested my patience, but by subtly tweaking the hitboxes, we finally got Billy from looking like this to this. Wait, shh. Do you hear that? Is that freedom I hear? That's right. We're adding guns to the game now. Rip the assets straight out of the Duck Game, and now it's... Oh, hey, look, it's me traveling to Ontario for a month for a program called Chad. Anyways, first, I fixed a small issue where having lower frame rates completely changed how the player moved, since I ran my physics based on every frame of the game. We do this by multiplying each value by the time it takes between each frame, meaning the physics would be based on a clock instead of relying only on frame data. Back to implementing shooting, I added a bunch of sensors to Billy so he knew what he was going to be pointing and blasting. After figuring out why my bullets were staying perfectly still after being shot, I froze their position at spawn. I fell into a coding conundrum. You see, I wanted to implement a simple mechanic.
When you're too close to a wall, the gun should go up. And for that, I wrote this massive amalgamation of code that didn't even work. Then my friend Roy comes along and says,
Hey, why don't you just add a different sensor for the wall?
Reducing the code from 26 lines to 1.
alright, enough of that. Now it's time to implement angle shots. Oh, what are angle shots, you asked? Well, it looked a little bit like this.
Angle shots are actually harder than they look, you know? In between certain movements such as hovering from a jump and changing directions while hovering, there are a few frames where the gun is facing at an angle. And if used at just the right moment, the bullet's trajectory will follow the direction of fire, making for some crazy plays. Fun fact, while working on the recoil, I figured out that Unity is really broken. In the transform function, which is how I'm finding direction, I found out that Unity doesn't have a left direction. To do that, you need to find the negative direction of right. Wow, great system from small indie studio Unity. Wow, so great. Good job.
Anyways, with all that wrapped up with a guaranteed bug-free experience 40% of the time, it was time to start training the AI. I'm going to use a deep reinforcement learning method known as self-play, and here's how it works.
Say you had two opponents you could play against in chess. One is your little brother, only smart enough to know how the pieces move and nothing else. Easiest opponent of your life. And on the other hand, we have Grandmaster Ariam Abreu Delgado, bringing his A game to every match you'll have against him.
In both scenarios, you won't be learning much.
The AI equivalent of this is either having your opponent move completely randomly or have a hard set algorithm that perfectly calculates the best optimal moves one can take. An AI can't really learn much from either. If only there was a way to fight an opponent that's exactly the same strength and intelligence as you. Oh wait, it's in the name. That's right. By cloning the winning AI and mutating it, we get the perfectly balanced scenario where by the means of natural selection with bullets, the AI slowly learns to grow into the perfect duck. We feed it information on screen every frame, such as the enemy position, its own position, where every bullet on screen is, etc., etc. Using this input, the AI pushes it through a neural network and, using its computer magic, gives us an output. To tell the AI how to improve, we'll also need a reward and punishment system that tells the AI that shooting at walls are bad and at players are good.
And nothing works. The character could somehow jump higher in this sped up environment, and now it spams bullets as fast as possible. I took 3 days testing, retesting, trying to figure out what was going on. I was so desperate at a point that I actually posted my issue onto the Unity forums. Nobody responded.
After some more debugging, I somehow fixed it. Turns out, I punished the AI the more bullets it had in its magazine, making it optimal to end a round with the least amount of bullets as possible. Reading through a bunch more documentation, I realized that I had a set movement on a fixed timescale. By moving everything that moved the character into a more stable environment, it seemed to have fixed the issue. So after editing the map and many more hours of training, I called my friends for the final test.
Okay, bye-bye.